Hello and welcome to the first episode in the series Calculus 101. And today we're going to be talking about limits. Let's get started. So let's say that we have a function where f of x equals 3x minus 6 over 3x minus 6. What happens when x equals 2? That is when we have a problem. So when x equals 2, we're going to be having 3 into 2, which is 6, minus 6, which is 0, divided by 3x minus 6, which is 0. And if we ever have 0 divided by 0, or anything divided by 0, the value is undefined. So if we were to draw this graph, how would it exactly look? With a hole at x equals 2. A hole basically symbolizes that there is no value at that point. At this point, when x equals 2, there is no value of function. So basically what we're trying to say is f of 2 is undefined. Now this is very important to understand, but how does this tell us anything about limits? Let me explain. So what a limit is supposed to do is find the value that f of x is approaching as x is approaching a certain number. I'm going to be using the term approaching a lot in this series whenever I talk about limits, because when we're talking about limits, nothing equals anything. It is always x is approaching some number, or f of x is approaching some other number. As you can see in this function, x can never equal 2. So that's completely out of the picture. So we have to talk about, as we are getting closer and closer to the value of 2, what is the value of the function equal to? So how is this actually written? How do we notify the reader that we are trying to find this value? It is written as the limit, lim, as a short form for limit, as x approaches 2, approaches with a symbol of an arrow, of f of x. Now we know that f of x continuously equals 1, and we have to find what happens when x is approaching 2 from both the positive and the negative side. So the first thing we'll want to do is take out a calculator and take very small increments of x close to 2, like 1.999 or 2.001. So let's plug them in. If we take our calculator out, we can get 3x minus 6 over 3x minus 6, which equals 1. So obviously this is a special function where the entire function simply equals 1. There are other values, there are other functions, of course. So this is pretty simple. So we can say as x is approaching 2, f of x is approaching 1. And that is how we write it. Now this may be some fancy notation, the limit and everything. However, this is extremely important for understanding calculus in general, since this provides us an understanding for the first branch of calculus, differential calculus. And differential calculus is extremely important for the second branch of calculus, integral calculus. So if you think about it, limits is the fundamental base for calculus in general. So let's say that this is a function right over here, and what I want to do is find the limit as x approaches negative 6 of f of x. Now the first thing that we can generally simply do is plug in the value that x is approaching into the function, and usually that's correct, of course, unless the function is undefined at that point. Interesting note right over here. This, I believe, you should take down because it's extremely important. For any polynomial p of x, the limit as x approaches a of p of x equals p of a, unless p of a is undefined. In the last example, I took it when p of a was undefined. So let's see what happens in this example. If we plug in negative 6 into the equation, we get negative 6 squared, which is 36, plus 4 times negative 6, which is negative 24, minus 12, negative 36, is equal to 0. Same thing down, that's negative 6 squared, that's 36, plus 6 into negative 6, that's negative 36, which once again gives us 0. So it's undefined. However, one thing that I think everyone should remember, all their teachers bombarded you with this one statement: first factor. In this polynomial, the first thing we must do is factor. I should say rational expression, actually. So let's factor this. So this can be x, that would be plus 6, x minus 2, and that will be x into x plus 6. What do we see? X plus 6 simply cancels out, so we can cancel them out. So now what expression do we have? It's now equal to x minus 2 divided by x. So now let's try and plug in negative 6. What do we get? F of negative 6 is negative 6, negative 2, that's negative 8 over negative 6. So we get 4 over 3, which approximately equals about 1.33 recurring. Voila. This was quite a tricky question because, as you've seen, a general person may do this, so just 0 over 0, it's undefined. However, that is incorrect, and we can actually factor them out. Always remember to factor the expression before doing anything. If you're trying to operate on it or simply find the limit, always factor first. Let's do another example. This right here is what you can call a piecewise function. It's represented with a bracket and then 2 parameters. So when x does not equal 3, it's x cubed. And when x equals 3, it's simply x squared, or I could have simply just written 9. So let's see how the graph would look. Okay, pretty straightforward right over there. This would always be x cubed, but when x equals 3, the function would be x squared. Or I could have simply just written 9. So my question now is simple. What is the limit as x approaches 3 of f of x? Once again, the first thing we must do if we're trying to find a limit is to take values from both sides, the positive and the negative. So we are approaching very close values to 3. We never equal 3. Once again, important fact, we never equal 3, but we are getting very close values to it. Now you could simply think of plugging 3 into the function, but obviously you will just get 9, and that does not work when it's a piecewise function. Whenever we have a piecewise function, much like this one, you can never simply plug in the value. You have to find values of x extremely close to 3. For example, 2.999 or 3.001. If we plug them into the calculator, what we'll see is that it's approaching some certain value. This point right over there. So what is the value? So if I can get my calculator on screen right now, we can see if I simply plug in 2.999 cubed, what we get is 26.97. So what happens when I plug in 3.001 cubed? What we get is 27.03. So what we see is a converging point, that point being 27. You could have just simply thought of this as 3 cubed and simply plugging it in. We are plugging in extremely close points to 3 and seeing what the value is approaching. So we can say the limit as x approaches 3 of f of x equals 27. Hope you understood something about limits. This was simply an introduction into the subject. Now you may be wondering how limits will take you anywhere into calculus, but believe it or not, it does play a very important role into understanding the higher levels of calculus. Thank you so much for watching. Hope you enjoyed it, and until then, stay sharp.